Example 1, determine whether the following functions are equivalent using two different methods. So the first method I'm going to try is subbing in a value. Okay, so you can choose any value for x that you would like. I'm going to start with 0. 0, sometimes it's convenient to use because it would eliminate any of the terms that contain x. So for the function f at x, if I sub in 0, what will I end up with? Well, the first term will be 0, the second term will be 0, and the last term is 9. So the first polynomial will be reduced to 9. And in the second polynomial, if the first two terms are 0 because they have x's, we're going to be left with -5. So I have 9 plus -5, which gives me an answer of 4. So f at 0 equals 4. Let's now see what we get when we sub in 0 for x in the function g at x. The first bracket will be just left with 1. And then we're going to be subtracting a -3 if x is 0. And that would give us 4. So at an x coordinate of 0, both functions will be 4. Does that mean that they're equivalent? Well, not necessarily. It could be that these two functions just happen to intersect at the point 0, 4. So we're going to have to try another value. So let's pick, for example, 1. So if I sub in 1, what will this first bracket in the function f at x equal to? So it'll be 2 minus 4, which is -2, plus 9, which will be 7. And to that, I'm going to add 3 minus 6, which is -3, minus 5, which gives me -8. So 7 plus -8 gives me -1. So f at 1 is equal to -1. Let's see what g at x would equal to at an x value of 1. I ended up 5 minus 8, which is -3, plus another 1, which is -2. And from that, I'm going to subtract 1, take away 3, which is equal to -2. So -2 plus, essentially, 2 would give me 0. So at an x coordinate of 1, they're not equal. So these are not equivalent functions because they give us different answers for an x value of 1. So 0, 4 must have been a point where they intersected. Okay. Now, if it happened to be that they also intersected at another point here, you would have to check one more time to be certain that the two functions are equivalent, because these are quadratic functions, and quadratic functions represent parabolas that can intersect in two places. Okay. So a third point would need to be checked to make sure that the two functions are equivalent if the first two times show that they are. Okay, so that's method 1. Therefore, the functions f at x and g at x are not equivalent. And then let's look at another method that we can use to check for equivalency, and that is just simplifying the two functions to see if they simplify to the same expression. So let's start with the function f at x. I'm just going to rewrite it here. So 2x squared minus 4x plus 9, and to that we're adding 3x squared minus 6x minus 5. So since I'm adding the polynomials here, I can just combine the like terms right off the bat. So 2x squared and 3x squared gives me 5x squared, -4x, and -6x when combined gives me -10x, and 9 when combined with -5 gives me 4. So f at x reduces to the expression 5x squared minus 10x plus 4. Let's now take a look at g at x. We have 5x squared minus 8x plus 1, and from that we're subtracting x minus 3. I'm going to rewrite this so that I end up changing the signs of the terms that follow the subtraction. And now I'm going to combine my like terms. I only have one term, that's x squared, so I have 5x squared. Negative 8x combined with negative x gives me negative 9x, and then 1 combined with 3 gives me 4. So when I compare the two functions, they're not exactly the same. The x terms are different, so these are not equivalent functions. And again, we can write the therefore statement, therefore the functions f at x and g at x are not equivalent.